Hello, everybody. Today we are looking at day 4. On your packets there was an error. It says student handout 3, but it's really 4. Uh, and if you skip forward, you see that it goes from 3 to 5. So, this is the student handout for proportionality and graphs. So, use the information below to create a table to determine the constant of proportionality k. And the information below that they are talking about is that a bike rider cycles 18 miles in 1 hour. So, in 1 hour, he goes a total amount of miles, that is 18, which means that my ordered pair is going to be 1 for x and 18 for y. So, you're going to need to number this graph, okay? And one of the things that you should realize is that down here we have hours, and we can just increase our hours in single units. But up here, the way that I knew to order this, increasing 18 each time, was that I knew every hour he's going to be going an additional 18 miles. So, for example, in the first hour he goes 18 miles, and in the second hour he goes 36 miles. Now, the way to identify your ordered pairs are at these little intersections here. Sorry, technology. All right, these little intersections here are where your ordered pairs will occur. So every time the line intersects, we can find an ordered pair. So my first ordered pair is going to be 18 and 1 right here. Okay, so we have 1 on my x line, which you can tell it's labeled x right here, and 18 on my y line. So I'm going to move on down. So in 2 hours, how far does he go? Well, I can go back to my graph here. If I move up, I can see that he goes 36 total miles in 2 hours. Then I have to write my ordered pair for that one. All right, so then I can figure out how many miles he goes in 3 hours by following it up. I see an intersection and I can go over and see that it's 54. So in 3 hours, he goes 54 miles. Then I can write my ordered pair over here. So for 4 hours, I can go up from 4 and to the left and look and see that it is 72. So in 4 hours, he goes 72 total miles. And so one thing that I do notice is that I don't know if you saw this feature on Loom, but you can speed up my videos. So if I am going onto my loom, okay, and I come to this window, you can stop it and then change the speeds. So if I pick 2 times fast.
Hello everybody. Today we are talking about proportionality and tables. Relationships are proportional if they can be represented by the equation y equals k.
Alright, so it's going to speed it up. Alright, so what I want you to do is fill in the rest of these blanks, okay? And now K stands for my constant, and constant is a rate, meaning how many for 1. So how many miles does it go in 1 hour? My constant here is going to be 18, because that is the rate in which it is increasing, the miles are increasing per hour. If I wanted to find an equation for that, in order to find y, I could write an equation like y equals 18, which is my constant, multiplied by x. So whatever my constant is, I can multiply by x. So my constant is 18, multiplied by 1 gives me 18. Okay? Now my constant is 18, but I can multiply 18 by my x. So x is 1 times 18 will give me y, which was 18. If I had 2 on my x, I could do 2 times 18, which would give me 36, and 3 times 18 to give me 54. So I can replace this x with any number on my x line. So we're going to be comparing the two graphs below, and jot down your observations in the table. So one of the observations that I am making about these graphs here, if I'm looking at them, I can see that these graphs, both of these graphs, have straight lines. And a straight line is also called linear, meaning that it is a straight line, and that each of these lines passes through the origin. Now you might be asking yourself, what's the origin? And the origin is the point in the graph that is the coordinates 0, 0. And where that origin is, and it's very important to know where that origin is to this lesson, it is right here in the middle, 0.00. Now this is important to know when identifying proportions from graphs, because if the line passes through 0, that means you're going to be having a proportion. So if the line passes through, a straight line passes through 0, you have a proportion. So a graph is proportional if it is a straight line or linear and it passes through the origin. Characteristics of non-proportional graphs, for example, both of these I have to look at, and specifically in both of these graphs I do not have a straight line, not in both. Now also in both of these graphs, neither line they're passing through is passing through 0. Or the origin. Which is located on 0 on the x and also 0 on the y. Alright? Very, very important stuff. This can be very easy, right? So all you need to have a proportional graph is a straight line that passes through the center, the origin. And if it is not proportional, non-proportional, you may have a straight line, but if it's not passing through the middle right here, it's not a portion, right? And this one doesn't pass through the origin and it's curved, so that's definitely not a proportion. Alright, you can flip on over to the back. It says proportional relationships are linear and pass through the origin. It says graph the tables below and explain if they are proportional or not. So if it is proportional, that means I drew a straight line and it passed through the middle of the origin. And if it is not passing through the middle or the origin, or if it is not a straight line, then you are not going to have a proportional. So it will be non-proportional. So instead of not, you can write non-proportional. Proportional or non-proportional. All right, so uh, one thing that I'm hoping that all of us are able to do is to graph ordered pairs. Now, again, this is a sixth grade skill. So in example 1, my x is 1 and my y is 1. So I need to put a dot on that line. And I realize that this can be a little hard to see on yours. So x is 1, y is 1. So on my x line, which is right here, and then my y. All right. So if I really even needed to help you out a little bit more, I could color code these, I guess. But I'm not going to do that, I don't think, because I think that you guys got this. So x is 1, y is 1. So I always start when I'm graphing in the middle, and I go left or right, because x moves left or right. On your x line, and y moves up and down. All right, so what I want to look at is the ordered pair 1 and 1. So I'm moving left to right first, starting in the middle. I'm going to move right 1 and up 1, and I can plot a point right here. All right, and then on my next coordinate, I have x is 2 and y is 3. So I have to go over 2 and up 3. And I need to plot a point right here. My next coordinate is 3 and 5. X is 3, 5 is y. So I start in the middle. I go over 3 and up 5. On my next ordered pair, I have 4 is x and 7 is y. So start in the middle. I'm going over 4 on my x line and up 7 on my y line. And then for the last one, I have x is 5 and y is 9. So I can go over 5 and up 9, but if you look, there's no 9 on your graph. So we're not even going to plot that one, but I can draw an arrow connecting these dots and see if it is a proportion. So if I can draw a straight line right through, it should tell me whether this is a proportion or not. Let's find out if it actually is or not. So it needs to pass through this point right here. So as you can see, if I'm drawing a straight line right through that point, it's not going to pass through the origin. But if I want to draw a straight line that connects all these dots, I can start at this one right here. and see when I pass through all these dots, it is not going through the origin. There's some space here. So for this one right here, example 1 is not proportional or non-proportional because it will not pass through the origin. All right, so what I'm going to want you to do is go ahead and do the other two on your own, okay? I think you guys will be able to do that. Now remember, these have negative numbers, so if you are moving in the negative direction, you're going to be moving to the left on X and down on Y. So let's take a look at number 4. It says the number of feet in a yard can be represented by a graph. Which of the following graphs best represents Y, the number of feet in yards? Well, the number of feet in yards, there's 1 yard to every 3 feet. So if I'm looking down here at my graphs, I have to find an ordered pair that intersects at 1 and 3. So if I had 1 on A, it would need to intersect right here. And as you can see, it does not, because I would have 1 yard to every 3 feet. Again, let's take a look at C real quick. C, it's really hard to identify a unit because most of the time a graph's unit or the rate will have a 1 connecting it to its constant. So, for example, here, 1 yard is the same as saying 3 yards. So right here, you can identify your constant if you follow 1 up and it has an intersection here. All right, this makes this very unique because I can already tell that for every 1 there is 3. So for every 1 yard there are 3 feet. On some of these other graphs, it's really hard to tell. First of all, this graph doesn't even have a 1. This one does, but it looks like it's intersecting at 6. So for every 1 there is 6. For this one, also it intersects at 6. This one intersects at 1 and 3. So your answer for that one is going to be B. All right. Number 5 says, which of the situations best describes the graph at the right? So, it says A, each smoothie costs $3. Well, we have a 3 here. And so for how many would it cost for one? Or I could look right here. So one smoothie would cost $12 according to this graph, and that's not stating that number A. B, a runner can run 6 miles in an hour. Well, 1 hour would be equal to 12 miles. Can't be that one. All right, there are 12 cookies in a dozen. So 1 dozen is equal to 12. So a 1 dozen would be equal to 12 cookies. 2 dozen would be equal to 24 cookies. Or D, it takes 6 hours to travel a mile. 6 hours, 1 mile. It's up to you. I want you to circle the answer you think it is. All right, guys, that's going to be it for today. Take care and stay safe.